Welcome to the August 2017 AJP-Heart and Circulatory Physiology video table of contents, or from the editor's desk. Summer is winding down, kids are getting back to school, and many of you have extra time to dive into the great science in this issue. This month we have published one editorial, one review, 6 editorial focus articles, all with useful summary figures, and 17 original research articles. Our editors are excited about this month's issue and want you to get a taste of what's inside, so let's get started. Review on autophagy by Wang and Chu. The authors discuss the role of the autophagic process in the pathophysiology of cardiac hypertrophy and heart failure. Rapidly increasing evidence has revealed an important pathogenic role of altered activity of the autophagosome-lysosomal pathway in cardiac hypertrophy and heart failure. Although an early study suggested that cardiac autophagy is increased and that this increase is maladaptive to the heart, subjected to pressure overload, more recent reports have overwhelmingly supported that myocardial autophagosome-lysosomal pathway insufficiency results from chronic pressure overload and contributes to maladaptive cardiac remodeling and heart failure. This review examines multiple lines of preclinical evidence derived from recent studies regarding the role of autophagic dysfunction in pressure overload hearts, attempts to reconcile the discrepancies, and proposes that resuming or improving ALP flux through coordinated enhancement of both the formation and the removal of autophagosomes would benefit the treatment of cardiac hypertrophy and heart failure. Skova et al. Examined the effects of exogenous thiosulfate on hypoxia-induced hydrogen sulfide metabolite bioavailability in human umbilical vein endothelial cells. Under hypoxic conditions, they observed a decrease of GSH and GSSG levels in UVEX at 0.5 and 4 hours, as well as decreased free hydrogen sulfide and acid labile sulfide and increased bound sulfide. Treatment with exogenous thiosulfate decreased the ratio of reduced to oxidized glutathione to total sulfide of UVEX under 0.5 hours of hypoxia, but significantly increased this ratio in UVEX under 4 hours of hypoxia. These responses reveal that thiosulfate has different effects at low and high doses and under different oxygen tensions. In addition, treatment with thiosulfate also diminished VEGF-induced cystathione gamma lyase expression and reduced VEGF-induced UVEC proliferation under both normoxic and hypoxic conditions. These results indicate that thiosulfate can modulate H2S metabolites and signaling under various culture conditions that impact angiogenic activity. Takawale et al. Determined if overexpression of TIMP3 post-MI limits adverse remodeling and LV dilation and dysfunction in young mice using adenoviral constructs expressing human TIMP3 or no TIMP3, ad null, injected into the peri-infarct zone. There was improved LV physiology and reduced LV dilation after TIMP3 overexpression compared with the ad null MI group. Post-MI adverse remodeling was attenuated in the ad-TIMP3 MI group as assessed by greater myocyte density, less infarction expansion, and extracellular matrix disruption. TIMP3 overexpression blunted the early rise in proteolytic activities post-MI. A higher density of coronary arteries and a greater number of proliferating endothelial cells were detected in the infarct and peri-infarct regions in the ad-TIMP3 MI group compared to the al-null MI group. Chen and co-workers provide important methodological and anatomical information for everyone who used mouse models of myocardial infarction. The variability and consistency of the mouse MI model is a major concern in these studies. Here, MI was induced by left coronary artery ligation. The coronary artery was casted with resin and visualized with fluorescent imaging ex vivo. LCA characteristics and MI size were analyzed individually in each animal, and MI size was correlated with left ventricular function by echocardiography. When the main LCA trunk is ligated, This results in a large MI, but when a single branch is ligated, MI size is variable due to differing levels of LCA ligation and area supplied by the branches. During the ligation procedure, nearly 40% of LCAs are not grossly visible to the surgeon. In these situations, the surgeon blindly sutures a wider and deeper area of tissue in an attempt to catch the LCA. Paradoxically, these situations have greater odds of resulting in smaller MIs. Finally, Rengue et al. Examined the molecular mechanism involved in leucine's action on cardiac glucose uptake. Leucine curbed glucose uptake after insulin stimulation in both cultured cardiomyocytes and perfused hearts. Although leucine activated the mTOR P7DS6K pathway, the mTOR inhibitor rapamycin did not prevent leucine's inhibitory action on glucose uptake, ruling out the contribution of the insulin-negative feedback loop. Alpha-keto isocaproate, the first metabolite of leucine metabolism, mimicked leucine's effects on glucose uptake. Incubation of cardiomyocytes with C13 leucine ascertained its metabolism to ketone bodies, which had a similar negative impact on insulin-stimulated glucose transport. Both leucine and ketone bodies reduce glucose uptake by affecting translocation of glucose transporter 4, GLUT4, to the plasma membrane. Thank you for watching the August edition of From the Editor's Desk. There are many benefits to publishing your work in AJP. Please read our editorial in this issue. The editors and staff are here to help you and get your best work published. Please contact us with any questions or concerns. Please go to our website to see the latest calls for papers. I'll see you next month, and don't forget to send us your best work now.